there's no such thing as I'm 20% sovereign, So the upper layers of my stack are all fine, but then the data layers are not. Well, then you're not sovereign, So either you're sovereign or you're not, I think, pretty much. And now the journey to becoming sovereignty, that might be something different.
This is Sovereign DBaaS Decoded, a podcast for IT leaders and implementers looking to reliably scale database ops while maintaining control of their data stack. In each episode, we join industry experts to discuss the what and why of sovereignty and how you can implement the Sovereign DBaaS concept of your own using open source databases, deployment models, and tooling. Let's get started.
Hello, and welcome to 2026 second episode of Sovereign DBaaS Decoded. I'm Vinay Joosery, and this episode is brought to you by Several Nines. Today, we're talking about sovereign AI, specifically what it is actually, and its dependencies, where it sits in the zeitgeist, and practical steps you can take to begin building towards it. This is a podcast for an infrastructure and database operations audience, and we're going to keep it grounded in operating real systems, control planes, data planes, stateful systems, and data realities. So to help us unpack this, today's guest is Jim Dowling.
Thanks. You guys have me here.
Yeah, co-founder and CEO of Hopsworks. So Jim, thanks for joining us.
Yeah, it's great to be here.
So Jim isn't just coming at this as an exec. He's been publishing and teaching in this space. He's the author of a book, Building Machine Learning Systems with a Feature Store, Batch Real-Time Systems and LLM Systems, and a recent talk, Building a Secure and Scalable Ecosystem for Sovereign AI. And Jim was previously Associate Professor at the Royal Institute of Technology in Stockholm. So before we zoom into the definitions, let's set the stakes. Is sovereign AI a generally new idea, or is it the operationalization of a sovereignty conversation we've had for years now at the AI level, similar to how sovereign DBaaS encapsulates infrastructure plus databases plus data ops and automation?
Well, I think sovereign has both a technical component and then there's obviously a governance component to it. And from a technical component, you can say that a lot of the software that we've been building has been built to run on, let's call them hyperscalers, so American hyperscalers. And that software isn't necessarily usable directly on sovereign platforms. So your governance, if you're running on a hyperscaler, will be the rules of that hyperscaler and the legislation behind the hyperscaler, whether it's the Cloud Act from the US. So I think from a technical sense, a lot of the software we've been building has been tightly coupled to hyperscalers, and there is a need for alternative platforms in order for you to actually run sovereign AI systems. The hardware, you can argue whether it's sovereignty at the hardware level, but I work mostly at the software level.
Yeah. So before we put sovereign in front of anything, we have to define AI, right? A lot of people are treating AI as synonymous with LLMs, maybe ChatGPT, right? When in fact it is a subset. So how do you define AI? And what type of workload types dominate in your experience? Predictive ML, deep learning, LLMs, and a mix.
Yeah, I mean, I work at Hopsworks. We're an enterprise software company. We have a data AI platform for building and operating AI systems at scale. And so how do I define AI when I talk to someone? I mean, when I teach at the university, I say AI systems are systems that make predictions. So you have data somewhere, models are trained on data, and then we give it some new data and it makes a prediction. And that prediction could be, if you're an LLM, the prediction is what's the next token? The next token is typically, you can think of it as a word. It's often a subset of a word. And when you ask an LLM a question, what it's answering is, it's a prediction of the tokens that should come after your question. And now, you can say, well, where does it generate those predictions from? Well, LLMs build a model of the world through language. So when you're asking a question, it's using that model of the world to try and answer the question, and the output is a prediction. But similarly, if you talk about a production AI system for doing something like predicting credit card fraud or maybe doing personalized recommendations, these are not large language models. These are deep learning models. These are decision tree models, more classical machine learning. And those systems also make predictions. So you have a credit card payment that happens. You look at the amount, the user, where it took place. You look at the history of the transactions. You take all this information into account, and then the model will make prediction. Do I think this is suspected of fraud or not? Similarly, if you're browsing on Zalando or TikTok or one of these kind of widely used commercial entertainment platforms, social media, they're making predictions all the time. They're predicting what do they think will be of interest to you, what will you keep you engaged, how can I convert you maybe to pay something. So models ultimately make predictions, and AI is ultimately the science of predictions. So what do we see mostly out there? I think enterprises are still slowish in adopting AI. The main problem we always see is that you have to have your data house in order. So often, if you want to build a classical machine learning model or a deep learning model, you need to have your data in, let's say, structured format so that you can use it to train models and then use that data to make predictions. And we can see now with large language models and agents that enterprises can more quickly generate value and see the benefit of AI in their businesses, because you don't have to train the model. You can just take a pre-trained model, and because it has a model of the world through language, it can actually add value from day one. But I think enterprises have been slow, but the adoption in LLMs is unprecedented. I mean, I guess everyone's seen Anthropic doubled their revenue, I think 30 billion in 1 month in new ARR in March. I mean, this is unprecedented. So, we're going to see massive change in the industry and how we use AI to do every type of work. And most clearly, we've seen the change in programming. So, at our company, I think 95% of all code is written by Claude Code and not by hand anymore. So AI is upending industries, and it's beginning to take off, I think, in terms of speed of change, accelerate, as we say.
Right. So do the false, AI is equal to LLM equivalency? Does this cause damage in platform and strategy decisions, or?
It's a good question. I don't think so. I mean, we've always said in AI that you have machine learning and deep learning, and AI is kind of the overarching, the grouping that covers all of these different technologies, and they're still going to have a role to play, So in particular, when you build a production system, if it needs to make a very fast decision, large language models, as you probably know from using them, are not fast, and there's no path in the near future to having these respond in tens of milliseconds. So when you need fast decisions, we typically need deep learning models, or we need more classical machine learning models like decision trees. So they will all have a role, but I think we can see quite clearly that large language models can address a larger set of problems than classical machine learning can. So they're inevitably going to, I think, solve more problems in more spaces and upend more industries than classical machine learning did.
Okay. Yeah. So now moving on to sovereignty, right? Sovereignty is about control.
Yeah.
And we define, at Several Nines, we define control as, workload access and portability.
Yeah.
How do you define sovereign AI?
Yeah, I think, Jensen Huang, who's the leader of NVIDIA, talks a lot about sovereignty, and I think he mentioned numbers of tens of billions of revenue in sovereign AI revenue last year. What he really meant is that, we sold to a lot of companies, so they send a lot of hardware to Meta and X and these other companies, and governments they're basically saying, hang on, you guys need to buy GPUs because you need to have control over AI. AI is changing the world. So you need to have these GPU factories, which many countries are actually investing in. Now, is that sovereign AI? Well, from his perspective, it's a business opportunity. He can sell more hardware. But I think sovereign AI is really very tightly coupled to sovereign data, sovereign deep assets. It's really about, okay, if I'm building and operating a computer system, where is the ultimate control lying in terms of the governance? So if I'm putting my data, my private data, my sensitive data into that system, Will it stay within my legal jurisdiction? Will people that don't want to have access to it have access to it? Will that be a risk for my business? So sovereign AI is very similar in that it's basically saying, I want to understand and make very clear decisions about who has access and control of my data. And AI systems are powered by data. Databases are the underlying core technology that power operational AI systems. So I think sovereign, if you say, okay, what does sovereign mean? Well, it means that when I build an AI system, which consists of hardware, we've got software on top of that, we have data coming in, that if you have control and ownership of that data, and it will stay within the legal jurisdiction of your choice, it could be national, it could be pan-national, then you can say you have sovereignty. Whereas if you, maybe without knowing and understanding what happens when you put your data on Azure or AWS or GCP, and you claim, well, I didn't know that the Cloud Act existed, and that there's the US now have access to my data, and I won't know that they've accessed my data. Well, that's not sovereignty, right? I mean, that's you can do it because you think it's convenient, but you then have to actually do that consciously and understanding the risks involved in doing that.
Right. So is that the most common control illusion, so to speak? Something teams think they have, but they actually don't. They just, make a decision to put the workload somewhere, and then.
I think it's much simpler than that. I think we're really in a case where, it's in the olden days we used to say nobody gets fired for buying IBM. So if you have data and you would like to put your data to work in AI, it's not NVIDIA you go to first, right? It's companies like Databricks or even Snowflake, and then you have AWS SageMaker and GCP Vertex. These are well-known platforms for building AI systems and operating AI systems. And if you make a decision that you as an enterprise are going to invest in AI, you'll need one of these platforms because you're not going to build all the infrastructure and software yourself. So I think at the moment, because these platforms are quite dominant in terms of mindshare, if you're not going to pick them, you're going to find that you're going to get pushed back internally. You're really, in terms of crossing the chasm, they are the early majority, late majority. You need to have a higher kind of risk appetite. Is where we are today. So companies, I think, just say, well, I would like to be sovereign, but I can't take the risk because I'm going to use a company like Hopsworks, for example, my company, and well, who do you have as customers? And you could say, well, we have, Zalando, Ericsson, Saab, and these kind of well-known companies. But unless they're peer companies of yours in your space, and you look around and see what your peers are doing in your vertical industry, then you're not going to take. You're going to say, okay, it's safer to do this, even though you understand the risks of losing sovereignty. To say, well, this is kind of the lower risk choice. I think the risk of going non-sovereign has changed, and a lot of it has changed because of politics. So if you take a country like Denmark, previously the risk of sovereignty was not considered a big risk, and Denmark went all in on Azure and many other hyperscaler platforms. But now they've obviously reassessed those risks because the risk of having no sovereignty over their data and AI platforms has grown massively. I think both industry and government have decided, okay, we need to build infrastructure that we in Denmark can rely on because there's risk to our sovereignty if we don't.
Yeah, and there was this, I read about this story there where the politicians in Denmark, in Copenhagen and in Greenland were having meetings using Teams.
and again, it's just the convenience because they don't understand that there are alternatives. I mean, this week there's interesting news that France are trying to move off, the French government, I should say, are trying to move off Microsoft. And as you probably know, most governments in Europe run most of the services off Microsoft. But if you go back and look at what happened in a French courtroom last year, Microsoft lawyers asked, can you guarantee that all our data will stay here in France or in the European Union? And the answer was no.
Yeah, there was no guarantee.
There's no guarantee. And, you can take a decision as a government or a business that, okay, they're going to take my data. Is that a big risk? Or is it a bigger risk that the AI platform and project will fail because I chose a less well-known vendor or I decided to build myself? That's kind of the decision I think most enterprises face.
Yep. Okay, so moving on to the next thing, which is the AI stack itself. What does it look like? From bottom to top, you have hardware, infra, data layer, you have, the models, etc. Can you just walk us through?
Yeah, sure. It's going to be a simplification, right? So at some level, but you have obviously got hardware, and the key thing in hardware is that when deep learning arrived, we understood that normal von Neumann architecture CPUs like Intel and AMD x86 processors didn't really work. They weren't powerful enough. So GPUs, graphical processing units, were found to be very efficient at both training deep learning models. And remember, large language models are a type of deep learning model. They're what we call a transformer model. So the hardware is very much about what we call hardware accelerators, not just for training them, but also for serving them, so making them available for use. And there is some specialization happening in terms of differentiating between training and then inference. So inference has this slightly more high bandwidth in terms of memory, and there's some interesting things happening there. But generally, you have to have hardware. And globally, there's a number of players. There's NVIDIA are massively dominant here. You've also got AMD with ROCm. And then you have Huawei are starting to make moves, and Google have TPU. But they're kind of the four global hardware players that we have. On top of those, they have a software layer, and NVIDIA have a software layer called CUDA. It's often considered their moat, because nobody else can, because a lot of the frameworks that run on top of the NVIDIA hardware use CUDA. And to make those frameworks run, so frameworks would be things like PyTorch or TensorFlow or some of these other high-level machine learning frameworks for training and operating models, to port them to AMD is hard. Pre-Claude, it was hard. Now post-Claude, we'll see an acceleration, I think. I was at an interesting conference last year, Ray conference in SF, and I saw a few talks on Huawei hardware accelerators. They're being used, and Google's TPU is quite widely used. So the hardware layer is the bottom layer, and then we have the software on top of them. I think we're going to see a lot of changes in terms of compatibility, because the companies like AMD will be making more of an effort to be compatible with CUDA so that more software can run on their hardware. And then above that, we have a layer of software that we use for training models and serving them. And they're kind of different software stacks. So you have frameworks like PyTorch, which is an open source framework, is the most popular framework for training both large language models and other deep learning models. And then you have like more classical machine learning models like XGBoost. But these are all pretty much open source software. So everything there is open source. When you're serving these models, so making them available for use, again, open source dominates. So there are frameworks like VLLM, which is widely used. NVIDIA has its own Triton framework, but again, you can go open source on that whole layer for training and inference. And then you have frameworks that will orchestrate all of your compute, right? So manage your GPUs at scale and be able to run training jobs at scale. There's frameworks like Ray, frameworks like Q, which is run on top of Kubernetes to manage GPUs at scale. And so our platform Hopsworks actually includes all of these frameworks, and we make them available and make them accessible in an easy way. And you can, of course, sort of put them together yourself, but it's a big challenge. Obviously, we have data then as well. We have large runs of data for training. So platforms like S3, we have a tiered storage layer on top of that. But you also will need real-time AI systems. So if you take TikTok, when you click and when you swipe and so on, there's a lot of infrastructure behind that for real-time data processing, for serving data on databases, so scalable, low latency access to data. Again, it's mostly open source. I think like all of the platforms pretty much powering these. We have an open source database called RonDB. It's a fork of MySQL cluster, and it's used at scale, handling hundreds of thousands of operations per second. But that's pretty much the stack from the bottom to the top. You've got the hardware. We have the frameworks for accessing that hardware, which are kind of proprietary like CUDA. And then we have pretty much open source for the rest of the way up the stack. So in terms of sovereignty, yeah, there is an issue with the hardware providers at the moment. It's not so easy to plug out one from the other. But I can see a future where they will be more interoperable and there will be some competition in that space.
And that kind of leads into in a way, you kind of answered my next question, which was, can you really reach sovereignty, right? Because obviously you mentioned the hardware, and then there's some layers of the software which is proprietary, but then there's a bunch of open source software which is kind of available readily, right? So
yeah, if you look at in Europe, we have a company called Nebius. They're ex-Yandex folks, and they've built large GPU kind of data centers in Europe. It is obviously powered by NVIDIA hardware, but they've kind of built this open source stack that I talked about. And if you're going to train models at scale, if your name is, let's say, Mistral or Anthropic or Meta or even OpenAI, they'll rent a lot of this hardware off companies like Nebius. I think Nebius had a big deal with, they closed a very big deal recently. I can't remember if it was Meta or AWS, one of those two. But if you're another enterprise where you're kind of, okay, we have our own data, which is stored in these data warehouses, we have our operational databases, we're all in the cloud, then it's harder for you to move to use a sovereign AI platform, because you're not going to want to move your data from where it currently resides to, let's say, a sovereign AI platform somewhere else, because what's the point? If your data's in a non-sovereign location, having your AI in a sovereign location kind of it invalidates the whole principle. Right. I think that's what we see a little bit with the gigafactories in Europe. There's a number of large AI gigafactories that are being planned. I don't see any data component to them. And then the idea is, well, what's going to happen? Will the enterprises send their data to the gigafactories, and then data has gravity, and AI should reside where the data is. So if you're going to pre-train a very large language model and you're Mistral, well, your data is basically a dump of the internet. But if you're an enterprise, you have all the interactions with all your customers, all the data that you've collected over time, and that data is probably not as well organized, and it's spread out. And the idea of shipping that to another data center that's sovereign, kind of, I don't think it's a winning idea.
Right. So coming back to this, software moat you mentioned, because that's one of the pieces of the stack which is kind of key.
Yep.
That that sort of NVIDIA owns, right?
Yeah, the CUDA, yeah.
So and with Cloud Code now, which is kind of eating up the software world, so to speak. How do you see this evolving?
There's an interesting story actually. Earlier in April, a GitHub issue was created on Anthropic's website by an AMD engineer. Now remember, AMD built this competitor platform to NVIDIA. They have their own GPUs. They have a stack called ROCm, but they would dearly like to have a CUDA compatible layer. This engineer had a very detailed analysis of how Cloud Code was performing more poorly since updates in January, and this is extremely high usage of it. So I don't know if you're familiar, but Cloud Code has a very heavy tail of users. There's a small number of users who consume an insanely huge amount of tokens. So this is one of those kind of very heavy users. So if I'm AMD, I'm going to use Cloud Code to build a CUDA compatibility layer as soon as possible, and then suddenly you're in the game. You can basically run your hardware. There are, of course, challenges related to how the software is optimized for your hardware, but over time they should improve with that. So I think the software moat that we've had before for system software, take for example, I build an object store, or I build even a database, or I build a file system. I'm not sure how much of a moat it will be in future. I saw another interesting anecdote on Hacker News recently, which was somebody has built an S3 and their own S3, and they wrote it in Rust. And I looked at it, I said, this is interesting. It has tiered storage and NVMe disks, and it's open source, MIT licensed. And I looked at just the contributors, and there was one person. And there was 150,000, 200,000 lines of Rust code. So obviously I haven't tested that platform. I'm sure it's not, production ready and so on. But just that you can get to the point where you have an S3 that has a lot of very good system properties. And in the world of S3, where we've got object stores, there has been one dominant object store, which is open source, called MinIO. they change their license.
They change the license, right?
They change their license, and then everyone's scrambling and going, okay, how can I get a good open source S3? There will be, there's a prediction. I think by next year, there'll be a good open source S3 that people are using. And I think it will be because of cloud code.
Yeah.
So moats aren't what they were in software. Even for a lot of infrastructure, I think we're going to find that those moats are not as deep and significant as we thought.
Yeah. So moving to another piece of the stack is the LLM piece, right? I mean, you've got the big known ones, obviously, from OpenAI, cloud from
frontier models, we call them.
Right. And then you have, Google, so these are the big ones, which, make a lot of money. Then you have the Chinese ones.
Yes.
There's a lot of open source, there's DeepSeek, which came in a big bang last year.
Yeah.
There's Gwen, there's a bunch of them. So where will we see the open source competing against, these frontier ones?
Europe, yeah.
Right.
So I think you can see pretty clearly that the frontier models are ahead, anywhere between 6 and 12 months ahead. And you say ahead of what, right? We take Anthropic, who are leading in terms of coding. They have obviously they have this new model Mythos, which they made a lot of news about, that it's too dangerous to release. It's so good at finding vulnerabilities in systems that it can be used to attack a lot of computer systems.
Which says something about all the vulnerability software that we have.
Yeah.
Which haven't discovered anything of these new things that have been discovered. Yeah.
I know. They claim they found a 23-year-old bug in BSD, which is known for its emphasis on secure software. But what you can see in general is the trend is that they're a bit behind. But you have to ask behind it what. So what Anthropic did was they basically said, okay, writing programs is something that we can verify. So if I write a program, if my LLM writes a program, and I run it, it'll either work or won't work. It could be an error or a non-error. And these are what we call verifiable tasks. So the LLM can be given a task, they can run it, and verify if it worked. And there's a post-training step called reinforcement learning that can work very well and fine-tune these large language models to work with verifiable tasks. And Anthropic invested very heavily in building out the infrastructure for these reinforcement learning with verifiable boards. This is what it's called. The open source models are a bit behind, but Quencoder 3, I think it's 3.2, it's a large model, I think it's 360 billion parameters, is really good. Where will it be in 6 to 12 months? It'll probably be where, Anthropic were when they released the new model back in November, December, I think it was. So, yeah, I think they're a little bit behind, but the question is, will we plateau? And we haven't plateaued, because we were plateauing in terms of just general chatbot behavior. You can say that, a large language chatbot model today is like Kimi. There's a big one, Kimi, which is over 1 trillion parameters. And it's as good as, it's as good as any of the chatbots, OpenAI models. But then for specific tasks like coding, there has been this large investment, but we'll see, I'm sure, the open source models catch up within 6 to 12 months. Then the question is, what will be the next set of verifiable tasks that the models will be trained on? Because obviously software engineering is a massively a lucrative task to be good at. Because programs are expensive, and if you can reduce the amount of programs you need, you can save a lot of money and spend a lot of money in AI. And they consume a huge amount of tokens. So, I think, the trend is that they're going to converge. The question is when, I guess, will frontier models always be able to keep an advantage? I don't think so, but that's my opinion. I've been, sometimes we're not always right. We'll see. I think is the way it will go. It's very hard to predict the future.
Right. So moving on from the stack and kind of going back towards the issues we see today, right? I mean, everybody's talking about sovereignty.
Yeah.
Right. This was huge last year. There's political, economic tensions. There's the long-term competitiveness of Europe itself, right? There was this Mario Draghi report. There are security concerns. There are supplier interests, right? Especially big tech. So, can you talk us through, how you see the problem, right? From hyperscaler dependence, data residency, compliance, vendor lock-in, right?
Look, I can take from the perspective of my company, Hopsworks. So we build what you might call a sovereign AI platform. So you can manage your data and you can train and operate models at scale. From a technical perspective, it basically meant we have to minimize dependencies. So we only run on Kubernetes and we require object storage. And typically you might need a container registry as well. So managed container registry is nice. So that means we can run on, effectively any kind of public cloud. So we have a lot of European clouds like OVH or Hubs, or they call the ones in Finland, Hubscale. I can't remember. Sorry.
UpCloud.
Or Stack It and so on. But also in your private, if you can air gap data center. So if I'm a company and I'm thinking about it, like I said before, if all of your data is in the cloud and you're already there, it's hard to extract from that. But if you're a company who hasn't made the jump yet, then you really need to consider, okay, what am I going to do? Am I going to do hybrid where I can move some workloads into the cloud and keep some local? And then those workloads that go in the cloud have data that I'm not so worried about. I think that's become quite a common pattern. We see also companies stay on non-hyperscaler hardware for economic reasons, for performance reasons. So what you'll find, I think, we as a data platform, so we have not just an AI platform, we also have a lakehouse. So lakehouse is kind of a scalable data warehouse. You'll see on hardware from OVH or even Hetzner in Germany, they have really great disks. They're NVMe disks, and your queries are much faster and lower cost than a cloud like Amazon. So if you're to get a high-end NVMe disk at Amazon, the price is insane. And they're not even as high performance as the latest servers you can get in the likes of Hetzner. So there are economic reasons, I think, as well. You can move if you have... I think what held people back was that they said, well, we don't have the competence. But now with Cloud Code, the competence excuse, I think, is less relevant than it was before. So some person who has, let's say, system administration skills, Linux skills, can do a huge amount more than they could, let's say, before prior to Cloud Code. Because Cloud can help you debug and find all sorts of issues in terms of... I can give it just an example. We were running... So we migrated actually Hopsworks SaaS platform from AWS to OVH. This is about a year and a half ago, before Cloud Code. And I think we saved 66%. We wrote an article about it. I think it was on Hacker News. But recently we've been doing a lot of our development workloads around AWS. And we decided, okay, this is post Cloud Code. We said, let's go to a lower cost provider, with better quality hardware. So we went to Hetzner, and we got a very big cluster now with high end. So you can get servers with 128 CPUs and, very large NVMe disks with getting 10 gigabytes per second or 12 gigabytes per second on them. And I think the cost is about a tenth of the cost. And then when people say, well, you're missing all the AWS services. Well, all we need is Kubernetes. All we need is S3. We just installed Proxmox. And Proxmox is an open source VMware kind of competitor from Austria. So it's a European platform. And it's so what we can do now is we can just plug in and say, okay, let's take any customer. Here's one running Ubuntu. Here's one running Red Hat. And Proxmox can spin those up. And then we can take the Kubernetes flavor they want and spin that up on top of it. So we can recreate customer environments really easy in this environment. And then we can do development in it, and you get shared resources. So if we do it as a kind of a startup who are, pretty technically competent, I can't see any reason why other companies wouldn't replicate that. If you can save 5-10x your costs in the public cloud, there's a high incentive to do it, because the work involved is not as significant as it was before.
No, you can use, you have a lot of tools. I mean, to actually help you move things and learn new skills and yeah.
Yeah, I mean, like, so you might say, well, how do I manage my machines? I don't know how to write Puppet. Well, Claude does.
Yeah. Well, before you would go to Reddit and you would copy paste, you will read blogs or Stack Overflow. Yeah.
But you also use that to LLMs. We've been using LLMs for a long time to basically ask questions, fix this, put in a stack trace.
Yeah.
It helps, but it's not the same as letting Claude go and fix the problem for you. And it does all. It's autonomous. That's the key difference. It's this agentic loop where it'll perform an action, look at the output of the action, and decide autonomously, and it'll ask you for feedback, periodically. Yeah.
So coming back to sovereign AI and databases, sovereign DBaaS. I mean, sovereign AI is only as effective as the underlying data, so to speak. Can you talk a bit about that relationship?
Yeah, sure. I mean, so do you know what the most valuable AI system in the world is today? It's TikTok. So TikTok, its differentiation is AI. It's I have 2 teenage boys, and I see how it's developed this kind of system for dopamine flooding, where they click and they get immediate rewards because the AI tracks what they're doing, and then it recommends based on what you've done 1 or 2 seconds ago. So there's no delay between you doing something and it being able to react to it. If you're getting bored or if you're getting interested, it reacts immediately. It knows, okay, you're interested in sports. I'm going to show you more sports, which based on what you've just seen, what you normally like, what your friends like, what's popular right now. And that system is completely powered by data. So every click that goes in, that is made in TikTok, needs to be ingested. You need to have very large, in their case, they're using Apache Flink, a European developed platform originally, developed at KTH partly in the beginning, actually, in my research group.
It was bought by...
So there was a company called Data Artisans out of Berlin. They actually were from the TU Berlin, so we had a research project with them called Stratosphere, where Paris Cabonia and Safari, who was also co-founder of Hopsworks, worked on the original streaming software that made it into Flink. But the team at Berlin at the startup, it was called Data Artisans originally, then they changed the name to repatriating, they're called now. But they were ultimately acquired by Alibaba for a very modest amount of money for the world's leading stream processing platform. But that platform is powering pretty much most of China. So when Trump threatens Europe and says, I want to take Greenland or whatever, the implicit threat is that they can shut down our digital infrastructure. China, if China had only built the clouds like Alibaba and Huawei and others, and they didn't have the trains that run on it, if they had like Databricks and Snowflake, then Trump could shut them down as well. But he can't because they're running on Flink. So what I would call, like, if you think of the clouds as being the kind of the railways or the railroads of digital infrastructure, you still need trains that do the hard work, that transport things. So these are the big data platforms like Snowflake, Databricks, and so on. So China have developed their own ones based primarily on open source software like Apache Flink. So getting back to TikTok, all the events that come in, they use open source Apache Kafka to ingest the data. They use Flink to process it at scale. I believe they're using Cassandra to serve that data at scale. So every time you click and you do something, it's going to compute what we call features. Features are signals that are kind of compressed signals that have a lot of information that the AI can use to make predictions. So you can give it raw data, but often it's too much data. The model will be too slow. So if you can compress that into a more efficient signal, like for example, if you look at the stock market, you wouldn't say all the stock prices for the last year. You might say the moving average for the last 30 days or the moving average for the last 180 days. And then people would kind of say, well, that's a signal of if the stock price is going up or down. The same might be for a user on TikTok. We'd say their activity levels for the last 10 seconds, 1 minute, and so on. So these signals are computed by Flink, and then they're made available in a Cassandra cluster. And then when you click, it's going to read all of the signals about what you've just done and your history and so on, and then pass them to the model, which will make a prediction and pass it back to you. So that platform, if we think about where does data fit in, it's all data. So the models are trained on the data that you've collected, and the data is used to power that system to give you this kind of dopamine induced, but obviously very successful way of interacting with social media, in this case videos. So that is the world's most valuable AI system. And if you move on and say, okay, we can go around. If you look at Claude Code, well, it doesn't work necessarily with databases. It works more with files.
Yeah.
So what Claude Code is, which is it's an agent, a coding agent harness. It's able to traverse your file system. It's able to look at files. It can run bash commands to say, don't read all the file, just give me the first 5 lines. So you'll see if you look at the command, it says head 5. Oh, it's a log, I'll go tail 5 and get the last 5 lines, because you get the last lines of the log. It's better than the first lines. And the program itself on the first lines. So Claude is intelligently sort of using bash tools in your file system to find the context information. That's the term we use, context, that is going to pass to the LLM to help them make decisions. So then you say, well, okay, that one was very successful. What's next? I mean, you can hear we're sitting in Stockholm. Klarna have made big noises about their reducing the amount of people they need to do support because they're using large language models. But the data that's feeding those models for support is not coming from a file system. It's coming from databases.
Yeah.
So it's your interactions with Klarna, your historical interactions. And then they might see there's, if there's a lot of people having problems at the same time, you might look for trends and recent trends, and all that will be fed in to the agents that they have that pass it as context to the models to help the LLMs give better answers. So like what an agent is ultimately is think of it as being a helper. You ask an agent to do something, you ask it a question. The agent's job is to find context data, so some external data that will help give a better answer to the client. So for example, if you're Klarna, you say, well, look, my payment that was made yesterday, it went through, but I don't think it actually went through. Can you please check it up? Then the context is obviously taking your ID, and obviously that needs to be passed to the agent, somehow your identity. And then it needs to go to the database platforms, pull out the information related to those transactions, maybe pull out information about other things that are happening, and then pass that to the LLM, which will do the reasoning. It will then be able to say, okay, this is what actually happened in human readable terms. So databases will power all of these next generation of systems. And, then it's a question of, well, do we do this with slowly moving data, what we call batch, or do we need to have real time? There's been a lot of talk of vector indexes and vector databases, because they can take the query that you put in and find related data. I think personally where we're moving is that agents will use a lot of identifiers. So you're going to have IDs for users, for orders, for products, and so on, and we can use those then to go to our operational databases and pull out the relevant data and pass that to the LLM as context. So I think databases are going to be key to taking the LLM, and the LLM, as we know, it doesn't have any memory. It's like the guy from Memento who couldn't remember anything. So what he used to do is write on his arm to try and remember. He'd tattoo something onto his body to try and remember it. So the LLM has no memory. It's an amnesiac. But what it can do is use databases as the memory, as the context store. So that when a question comes in, it can say, well, I don't remember anything that happened 5 seconds ago, but I can go to the database and see if that data is there and pass it into the model. So the agents will be the kind of the body that connects this brain that has no memory to memory in the form of databases.
Yeah. So we saw vector databases popping up, a couple of years ago, and is this still a thing? I mean, is it still a market? Because it seemed, there was a bit of a hype around those, but then you had vector capabilities being, introduced in, Postgres, MariaDB, so
we have it in RonDB as well. We have vector index support now in RonDB. I think, look, there's two things. One is vector. Why was there a sudden surge of interest in vector databases? And then the second thing is, do we need standalone vector databases? So for the first part, this was the problem. When LLMs first came out and chatbots first came out, people realized they can only answer questions up to their training cutoff time. They know nothing about what has happened after it. And then quickly people got an insight that if I ask a chatbot, which isn't just plain English text, what happened, I can use that question and go to a vector database and say, do you have any text which is similar to this question that might help to be added as context to the query? And the classic example was, I think, when Argentina won the World Cup, LLMs had just come out, and people said, well, who won the World Cup? And the LLM didn't know because it was trained just before the end of the World Cup. So somebody took all of the text in Wikipedia, put it into a vector index, a vector database. So you basically take pages and you turn them into chunks, and then you insert them into the vector index. And then you basically have your chatbot ask the same question again, who won the World Cup? The chatbot goes to the vector database with this question at the World Cup, finds pages related to the World Cup, puts them in the context, sends it to the LLM. The LLM suddenly knows, oh, I know who won the World Cup because you told me. It's in the chunk of text you told me. So Argentina won the World Cup. People go, wow, it's amazing. And I think it's still relevant. So that usage pattern is still relevant, but it's less relevant if you want to do, I gave the example of a Klarna, kind of, a call center, because the call center is not going to use your, text and probabilistically find some other text related to it. It'll use it for something like, what's our policy? So the user asked about returns. So there may be a PDF document related to returns, and we put that in the vector index. So you can look up that, and that will work. But when it wants to find information about you as a user, your orders, your payments, then it's classical databases that will use to return that data. So then the second part of the question is, do we need a vector database?
Now that everybody else have added those indexes.
I think, look, in general, if you go back 30 years ago, Oracle said you only need relational databases. We don't need anything else. But as data volumes increased, lots of databases became viable. I think the vector database is viable as a segment. I think, however, it's maybe grown a bit too fast, too quickly. There are a little bit of inflated expectations there that this would be the only database for context for LLMs. And if you just need just like now, if you don't have a huge volume of data, let's say I've got like 500 gigabytes of data, I'm not going to connect up a data warehouse. I'll just run an operational database. I'll do Postgres, MySQL. I can do analytics on it as long as it doesn't kill any of my operational workloads. But when your volumes increase, you got tens of terabytes of data, then you're like, okay, I got to offload this onto my data warehouse. So I think you can see similar kind of work patterns for vector databases.
Yeah.
That if you don't have that huge, but you also see vector indexes appearing now in data warehouses and column data. So there's a file format called LATS-DB, which is for storing huge volumes of data in a vector index. I think the challenge with that is that they're very expensive to compute. You take a chunk of text, you have to run it through an embedding model, which typically requires a GPU. So it's not like a database where you can insert 100,000 rows per second.
No.
Here you have to have a GPU take that text and use an embedding model to compress that text, and then only then you can write it. Like we see at one of our customers, about 30% of the GPU work goes in fleet of GPUs is just computing embeddings. And so it is quite expensive.
Yep.
So they're not, they have their use, but I think it'll be niche-y.
Yep. Yeah. So I guess the answer is definitely we need a lot of context, which means putting the data somewhere.
Yeah. And the trend is still there that as data volumes keep increasing and agents will create more and more data, that we're probably going to need more and more specialized databases. Yeah, that trend is being inexorable, I think.
Yeah. So moving up to a more macro level, we are in Europe, right? Europe has very few AI infrastructure companies, right? I mean, probably Mistral is the main LLM provider. We have data AI platform, Hopsworks.
Yeah.
We have a number of those smaller national, cloud service providers that are providing, GPU as a service. So what do you make of this kind of, landscape here in Europe, the AI landscape?
Yeah, I mean, a lot of people say there's no AI companies in Europe. I mean, excepting Mistral. So Mistral, as train their own large language models. They're ex-Meta folks. They were a lot of capital investment, and they do a good job. Hopsworks are a data AI platform, so we're an alternative to the Databrickses of this world, where you can store very large volumes of data. You can train models at scale and manage fleets of GPUs and serve those models at scale as well. But it's lonely. Like we don't have any competitors in Europe, so we're competing globally. The companies in Europe that have been so what's happened in the AI space in the last 10 years is that startups in particular have specialized in certain parts of the life cycle of AI. So you might work on, let's say, preparing data for AI, so scalable feature engineering, or you might work at training models at scale, or you might have some sort of training infrastructure and managing experiments. So we had a few of those companies around Europe. An example would be one called Neptune. They were doing very well for saving models in a registry and managing experiments, but they were acquired by OpenAI and recently. I think that's a challenge we have in Europe, is crossing this chasm. Crossing the chasm is a well-known book for entrepreneurs that when a startup gets to a certain size, they can get the first customers can be really innovators who want to try out something new, but then you got to get to the early majority, the people who want something stable that really delivers value. In America, that's really considered a customer acquisition problem, but I think in Europe we also have a slight cultural element to it. Right? So if you take all the startups that get acquired early, we worked at MySQL many years ago, they were acquired way too early because the explosion in data was barely starting. They could have been acquiring companies like MongoDB and Elastic, which started in Europe as well. Elastic was a Dutch company. But what happens, or what we've seen to happen, and we saw it with, I mentioned Flink earlier, is that we have this cultural, I'll call it the European crossing the chasm cultural challenge, where your peers, your friends, your family will say, oh, you got an offer, 90 million for your company. That means like a few million for you. You can buy your house, you can buy your summer house, you can be sorted. This is, because in Europe, that's what you need to be happy, financial security for life. And you don't need more than a few $1 million in Europe to get that. So the ambition that, no, I want to build a kind of generational company or something like that, it isn't as strong here, I think. I think a lot of people, there's a lot of cultural pressure to say, hey, here comes the offer, that's it, you're done. But for Europe, that's not good as a whole, because we need to have technical companies that show leadership. And I think Mistral are doing a great job. I think we need a lot more. And we need them higher up in the stack. They're really just doing the foundation models. We're trying to do it at Hopsworks to lead the data AI platform, but we need more.
Yeah. So there was, I mentioned there were these smaller, let's say national cloud service providers, right, providing sovereign AI services, right? But then you also have the hyperscalers, Amazon, Google, Microsoft, Yes. They also market sovereign cloud services in Europe.
Yeah, I mean it's sovereign washing, right? Like it's, what they're trying to do is give arguments to their prospects, to the customers, say to go internally and say, well, I'm picking Amazon because they had this nice white paper saying that we're sovereign, or Azure claimed they're sovereign and said, we'll never give out your data to anyone. But we've seen what Microsoft did to the ICC prosecutor in Asia, that we shut off his account because, well, why? They never explained why. I think there was also a bank in the Netherlands who, not under American jurisdiction at all, but they shut them off. A Russian bank. This is a couple of years before, I think.
That was when Russia invaded Ukraine, and this was a Russian bank.
Yes,
I think it was like the Trade Bank or something. It was called the Trade Bank. It went bankrupt, but then they couldn't get the data.
Yes,
the data
which had huge implications for a lot of the creditors in Europe, I believe, and it was an extrajudicial kind of decision. So outside of the European Union, outside of the governance area for that bank. So, I think the sovereign washing is going to be a thing, but the problem, the challenge we have as an industry in Europe is, I take our company, we're like really the only data AI platform. We have no money, we have no time to go to Brussels to argue on our behalf. But these companies have lobbyists, armies of lobbyists, trying to ensure that whatever happens in terms of rules and regulations will benefit them. And this is something where I think we need political leadership that actually is aware of what sovereignty actually means. They need to know if Amazon say it's sovereign, that doesn't mean it's sovereign. And the same is true of GCP or AWS and so on, or Azure as well. So I think the funny thing I see in Sweden is that I don't see leadership coming from the government. Actually, funnily enough, I think it's coming more from industry. So we have customers like Ericsson and Saab, and they care about sovereignty. And we see government departments like the tax authority were announcing on LinkedIn the end of last year that they proudly moved to Azure. So all our tax data is now in Azure. Doesn't feel great. I don't think so. I think I would like to see more of an effort to build the European infrastructure that we need. I think the companies are here. I think we just need to a kickstart. That'd be the going.
So, to start, weaving sovereignty into the AI data stack, how would you say a team can begin building towards, sovereignty?
In AI, it kind of depends. Are you going to be a user of AI? Are you going to just use LLMs to maybe you want to build a chatbot internally? Maybe you want to have a customer support page and so on. There are a lot of, let's call them LLM providers. So in Stockholm, we have, there's a couple I know of that run out of data centers here. Very secure data centers. They're kept in Sweden, and it's fine to use those kind of companies, of course. There's another one, 6G AI as well in Kista. But those companies are fine if you're just going to use an LLM. I think if you want to now integrate your own data with the LLM, then we're into more maybe I'll need a data AI platform, something like Hopsworks or some other platform, and then it's really about your starting point is in which jurisdiction will you run your servers? Will you run them in a sovereign cloud like in Europe, or will you run them on a hyperscaler that's under the US Cloud Act? And obviously, if you go to hyperscaler, then there's no point. There's no point in building a sovereign stack on top of it when all your data is still covered. So I think, if you really care about it, you're going to go with some sort of cloud provider or data center that maintains sovereignty, and then you need a stack on top. And at least us as a company will help you manage the data and also manage the AI from all the entire life cycle. You can, of course, build it yourself. I mentioned Nebius earlier. We're a very large GPU data center provider. They do the product globally. I think they had 250 engineers they took from Yandex. They patched together a lot of these open source platforms, and they provide similar tooling capabilities. So I think there's some alternatives there. And if people want to learn more, they can always reach out. I can help them talk to them individually as well.
Yeah. So starting point is get a sovereign platform, infrastructure as a service platform,
databases, all of that. I think.
Yeah.
I think I've heard the question: is sovereignty binary, or is it sort of a?
Is it more like a spectrum?
Spectrum, and I think it's obviously, from my perspective, it's binary. Right? There's no such thing as I'm 20% sovereign, So the upper layers of my stack are all fine, but then the data layers are not. Well, then you're not sovereign. So either you're sovereign or you're not. I think pretty much. And now the journey to becoming sovereignty, that might be something different. Maybe you're on a hyperscaler right now. You're based in Denmark. You're very worried. How do you move from here? Well, of course, you can move your software in the cloud. You can stay in the cloud and start moving towards platforms that can migrate with you to a sovereign cloud. And that might mean leaving Databricks, for example. You only run on US hyperscalers, and you got a plan for that.
Okay, so we'll thanks for that. We're going to start wrapping up here. So to summarize, AI isn't just LLMs, right? Since last year, we probably have reached peak sovereignty, rhetoric, right? Although we still have to see things in practice. So Gartner's terminology, we are at the top of the hype cycle, right? But we haven't reached the plateau of productivity yet, right?
Yeah.
So I think there is a long way to go. Organizations need to watch out for sovereignty washing, right? From the hyperscalers, right? Which creates a false sense of security. And one should not confuse data residency with sovereignty, right? And sovereign AI depends on a sovereign data layer, right? So you can't have one without the other.
Of course.
And lastly, Jim, I'll ask you for some prediction here, right? If you had to guess, where would we be in the next, let's say, 5 years?
5 years, a long way out. I mean, I think so that we've seen software engineering upended in the last 6 months. And if we go back to deep learning revolution, which started around 2012, it started out with kind of image classification and moved into video and moved into translation and so on things, but it took a long time for it to play out. It was slow. This time we're moving incredibly fast. And the hammer that is large language models is a bigger hammer that's going to hammer a lot of different industries. So anything that's verifiable, as I mentioned earlier, tasks that you can verify, will be able to fine-tune these models against and be able to get them very good at them. So things like mathematics as well, we've seen as well. It's hard to predict. So I can basically say that the tasks that are verifiable will become much more AI supported, and that means a lot of industries. I mean, we can see industries like legal industry; it's completely going to be upended. So my prediction about next industries, I think industries it's hard to tell. But yeah, I mean, here's a prediction. I think unstructured data. I think we're going to see there's going to be a revolution that unstructured data will become structured. So I mean, we will work with some customers who do things like store a lot of data in PDFs, and then they've got spreadsheets to kind of link things together. But those kind of workloads will migrate to databases because it's easier, because it'll become much easier to do things properly. So rather than kind of, people say Excel is the biggest database in the world. There's a prediction. I don't think it will be in 5 years. And it take a while to get off it, but it'll happen. I do think SaaS is in danger as an industry because I see it myself. We've migrated off a bunch of SaaS platforms internally that cost us money because it was easy. So SaaS won't be the moat it was. I think there's going to be way more software. I don't think I'm alone in that prediction, but I'm writing tons more software than I was before. So we're going to see a much larger number of people, I would say even a majority of people, building software in the future. And that's going to be a revolution by itself, that we have marketing people here who write software. I think a majority of professions will write software in some way or form in the next 5 years.
Excellent. Hey, this has been an enlightening discussion, right? Where can people follow your work?
I'm not active on Twitter, funnily enough, so much for political reasons, but I am active on LinkedIn. I do write occasionally. I write blogs on our website. I think, I have this O'Reilly book that just came out a couple of months ago. If you want to learn about how to build AI systems, so anything from batch AI systems, real-time AI systems, or agentic large language models, this covers the full spectrum. So it's really for, I would say, ML engineers who want to become agentic programmers, or agentic people who want to learn about ML, or data engineers who want to learn about AI. It's really for those kind of people. I think that's a really great resource. I'm going to be active. As a platform, Hopsworks, we're moving as well. I have a webinar today on how Cloud Code is using our platform. So we're building Cloud Code into the platform. And, if you want to learn about how to build pipelines with cloud code and in data pipelines, AI pipelines, then, you can turn up to some of our webinars. You find out a bit more.
Perfect. We'll include those links. Well, thanks again for joining us.
Thanks, Vinay, and thanks for having me.